Hi. Oh, sorry, it's a bit loud. Hi, my name is Sourygna Luangsay. I work as a big data architect in Bol.com. I'm going to deliver this presentation now. So it's make the elephant fly once again. Why exactly? Well, the elephant, it's basically our current Hadoop cluster on-premise. And we have some challenges, and this is why we try to go to the cloud. And well, the goal of this session is to see what we've seen in the cloud, what's good, and how it can improve our Hadoop cluster. So the agenda for today is going to be, well, we're going to describe a bit Bol.com. We're going to talk about data quality and a few topics about personal identification information, and then a few words about what kind of strategy you should adopt to go to the cloud, should you lift and shift. So Bol.com. This is basically web shop. This is the main web shop in the Netherlands, and now we extend to Belgium also. So this is the kind of web interface you could see, with a wonderful elephant, obviously. And what does it mean exactly when you are the main retailer, online retailer in the Netherlands? What kind of numbers you could expect? So we have on our catalogs 50 million products, and obviously, well, a lot of customers also. So that means that every day we have to deal with a lot of data. And for that reason, well, our current Oracle data warehouse cannot handle with this kind of load, and we've been working with Hadoop for quite a long time. Actually, for nearly 10 years now. This was our first Hadoop cluster. So it's a bit experimental, and well, that was a POC. And now, currently, well, obviously, that has grown. Our Hadoop cluster on production is 35 nodes. And we have a lot of teams, IT teams using it, and also different business people, business teams using it for reporting purposes. So you can see also some of the technology we use. And as I said before, we face a lot of challenges. So those are the kind of challenges we have. For instance, we're using Hortonworks. We have just one single version of Hortonworks. And having just one version of the software does not give enough flexibility for all the teams we have. There are some teams that would like, well, the newest versions, other ones that are more kind of conservatives. We have also some problems with flexibility with, for instance, the peak. On Christmas, well, this is where we sell most of our products, so we need more Hadoop power. But the rest of the year, we don't need as much. So a Hadoop cluster on-premise does not give you that. We also have some problem with securities and also with the load. That is, well, many teams, we have more and more teams working with Hadoop. So we don't have now enough servers on our clusters to give all the CPU, all the memory those teams would like to have on Hadoop. So this is why we're running to the cloud, or at least this is what we want to have. And so we first want to try to go to Google Cloud. So we are doing now some POC with Google Cloud. Why Google? Basically because we said, OK, those guys have totally invented Hadoop, so maybe they're the best player to give a try. So when you want to move to the cloud, the first thing you have to do is to take your data and you push that to the cloud. So I tried it first with Hive, and the equivalent for Hive in Google is BigQuery. BigQuery is the big data warehouse of Google, so it makes sense. It's to push it to BigQuery. It also has a kind of SQL interface. And pushing the data to the cloud is quite easy. The only thing you have to do is, well, those 3 commands, and works pretty fine, so no problem. But then you have to do the migration for the second steps. That is the ETL. All the ETL queries you write, well, you have to translate them to BigQuery. And this is more tricky because, well, we all say, well, SQL is kind of standard, but you all know there are some kind of small differences. And you have to deal with those small differences between Hive and BigQuery. If you don't take care about that, then you're going to have some small differences in your data. And this is where you have a problem with data quality. This is, well, when the business people start to get angry And this is a situation that already happens in our Hadoop cluster and our Oracle data warehouse. So we have some data sets that are both on Oracle and on Hadoop. And the business people say, hey, some of the data sets don't have exactly the same data, and they really don't like that. So we need to take care about data quality. What does it mean exactly? Well, that means that when you do migrations, you have to make sure that the data you have on Hive, on one table on Hive, is going to be exactly the same data you're going to have after your migrations on BigQuery. So there are different ways to do that. The first way is don't do anything. And that works. That works fine. I've seen several companies doing that. I mean, they migrate their stuff to the cloud, and then they say to their boss, OK, see, the data is there, working fine. With BigQuery, it works faster. And then don't do any test. Well, obviously, they get some problem later. The other way to do that is to do some quick tests. This is the first approach when people try to check. So it's very basic. You just count the number of rows. OK, is it the same numbers on the same on the two tables? And then you do some quick checks on the first lines. So that works, but obviously, you won't check all the data. So you're going to be 100% sure that your migration is actually working fine, and you have good data quality. So in order to get sure, I remember in the past, I was working on Hortonworks, and we did different software to try to solve this problem. And recently, I improved a bit some of the works I did before, and I created a validation tool. So this is the one I want to demo now. And the goal of this validation tool is to check all the rows, all the columns. And it also removes some of the problems I've seen on other tools, just like, well, doing some scoop steps that are very annoying. Also, well, many approaches to do a comparison between two tables are doing some joins. This is very inefficient, so I removed that, and the tool is totally scalable. It's working with BigQuery and Hive, so you can compare, well, those tools. It also works with HBase, because actually you can build a Hive table on top of HBase. And, well, this is an open source project, so if you want to play with that, well, you can check this on this URL. And now, let's do a quick demo. OK, and this is where I got some problem with PowerPoint. OK. So I'm going to compare two tables. So first, let me show you, well, BigQuery. This is BigQuery, OK? So, well, you don't see perfectly, sorry, because of the resolutions. So this is a default table you can find, a public data set you can find on Google. This one is called Wikipedia. And, well, you can see, well, different columns, different types, OK? So what kind of table is it? How big is it? So here you can see we have 35 gigabytes and more than 313 million rows on these tables. And you can have a preview of your data. OK, so those are some few lines. And we're going to try to compare this table with a second table. So the name of the tool is Hive Compare BigQuery, but here I'm not going to compare Hive because Hive is quite slower, so I don't have a lot of time on this presentation. So we just compare two tables from BigQuery to BigQuery. So I'm going to take one view, and this view, here you can see, this is exactly the same table we've seen before, OK? And now let's imagine we have a second table that would be the result of, well, an ETL process that has been migrated. And let's say it has an error. It has, let's say, just one row of error, and you change one data in one column, OK? And the rest is exactly the same. And we're going to try to see if our program is able to find the error in just one row of error in 300 million of rows. OK, so resolution is not, I don't know, can you see it a bit? OK, so how does it work? Well, you launch the Python program, and you just have to specify, well, that you're using BigQuery here. If it was Hive, then we would write Hive. And then, well, the name of the data set, the name of the two tables, so the source of truth, and then the Wikipedia by data. And then the program runs. So first thing it does a quick analysis in order to pick the best column to do some kind of optimization of the group by. Let's see a bit what we have now on BigQuery. So let's go BigQuery analysis, BigQuery history. Okay, so this is the heaviest function. And this is the kind of query you execute when you run this program. So once again, resolution is not perfect here. So this is the query you run. So there are a lot of hash functions that are being made. Basically, this is because all the columns are collected, all the values are collected, and you hash all those results. And at the end, you get some checksum, and you compare the two checksum, the one from one table and the one from the other table. Okay? So, okay, now you can see on the bottom, it says, okay, we found one difference in the checksum verifications, and now we're going to show that difference on the web page for a few of the columns. And here it is. So you can see here on the top, you can see that you have Wikipedia bad data, and the data that was wrong is in yellow. So you can see Google Cloud, that is the value we inserted manually. And now on the right, you can see Magnetic Cloud. By default, well, the program will show you also some good lines so that you can see what are the bad data and what is the good data, just like kind of referenced for you to help you in order to debug all the errors you've seen. Okay, so let's come back to the presentation. So, with this kind of program, you're able now, well, to check if the new ETL process you've wrote to BigQuery will give you some good results. But you can use also this kind of program not only to check your migrations, but also well, to check, to do some test coverage in your normal development process, okay? So that is, when you develop new code, well, obviously you can still do some unit testings, but you can also have a look with Hive compared BQ and check the whole data set in order to catch outliers or exceptions, whatever. Now, let's talk about another tool that is data prep. And this tool also can be used to do data quality. So this tool is not open source. This is a component of Google, also in the Google Cloud. So here on the right, you can see some image of data prep. To say a few words about that, I could say that, well, data prep is kind of an intelligent, visual, serverless data preparation. Those are the words from Google. It takes as an input either some files, from the Google file systems, so buckets, or BigQuery, as we've seen before. And then it's very focused for business people, so it's kind of Excel-like, very easy to run. If you want to know more about the tool, you can have a look at this as this link. It's a very good presentation from Google, very interesting. But I'm going to give you some few words about that. So when you use data prep, first thing you do, you will use a wizard that will load the data you have on the cloud into data prep. And then this is the view you would get. So the first thing to notice is that you can see your data. And this is something I really like. Because if you compare to, well, the jobs that are done by IT people to do an ETL process that will be done in SQL or Java, this is kind of very black box. The guys never see the data, or barely. And now you can do the transformation of data and see what you're doing. So this is a very good stuff. The second thing I like is the point number 2. Those are statistics. Let's zoom a bit on that. So you have a statistics for all the columns, and that gives you a feeling of what is the distribution of my data. Do I have some skew? Do I have some exceptions? Do I have also some mismatch values? So what you see on red, and well, maybe you don't see it well, this is actually a mismatch value. So you know that you already have a problem on your data here, okay? So very visual for you to focus on some errors to get a better idea of your data. What you see when you load the data and those statistics at the beginning, it's just based on a sample. We'll see later how to see the whole data set. Then, let's come back here and focus on number 3. Number 3 are the receipts, the transformation you're doing. And you can have a better definition on that, so you kind of click in order to unfold, and you would see exactly what is exactly each transformation. And as you can see, it's kind of text mode. It's very visual. And this is written in text so that, well, business people can really understand what they're doing, what it means. And also, well, as I said before, this is business people like. And now, if the business people want to do a new transformation, this is how the tool works. They can just take the data, underline some part of the data, and automatically, on the bottom, you can see, well, data prep will show you some kind of suggestions that helps you to pick up what is the best transformation you would like to do, okay? And when you've done all the transformations, then you go to number 4, that is, you push one button to run one job. And this is kind of a result you would get, that is, automatically, all the transformations defined by data preps would be compiled into a data flow job. So data flow is kind of execution engine similar to Spark or Flink. It runs on the cloud, it's scalable, and this is really fine. I mean, you've been able to define an ETL process without writing a single line of code. So that makes business people quite productive. And finally, when it's being executed, you get those kind of informations, that is statistics, but this time, those are not statistics based just on the sample. Those are statistics on the whole data set. And you can also see, hey, I have 1% of mismatch, 1% of missing values, for instance. You can see, well, the distribution of your data. And if it's not enough, then you can still, well, take the data that has been generated and look at your favorite tool, just like Tableau. And once again, no need to write a single line of code for that. So coming back to summarize on data quality, how can data prep helps you to improve your data quality? Well, for IT people that develops ETL processes, that helps them to have a better understanding of the data. And obviously, if they are able to pinpoint where are the outliers, the skews, before developing any code, they will be able to do much better code. Then for business people, well, it helps them also to get a better understanding of the data and, well, maybe to do a first analysis. That is, they could do a very quick ETL process, just as we've seen before, and when this is done, well, they get a better idea about what they would like to do, and they would create better Jira stories to push to IT. When IT has developed the ETL process, then they can, after that, validate the data set. That is, they take the data set, they run the jobs to get the statistics, and they can do a double validation. So very interesting also on the data quality side. Now, let's go on another topic about the cloud. This is security. Well, I think for those who might not know, this is the Kerberos dog. And, well, security is quite an interesting topic because at first, when you deal with the cloud, this is not kind of intuitive. You don't think that, well, I'm going to have a lot of security on the cloud, or at least from my side. And I know that our security department in Bol was also kind of frightened by the cloud. You have to push all your data in your company with some kind of very sensitive information, and you have to trace, a third-party company. And actually, it's funny because the cloud, well, our data on the cloud is going to be more secured than how it is now. So what is our current situation in our Hadoop cluster as for security in Bol? Well, we have some problems with Kerberos. I don't think we are the only one in the world. Well, some of the problem is, well, we have problems with integrating the Kerberos libraries into our normal Java processes. There are kind of conflicts, and this is one of the reasons why teams try to avoid using Kerberos, at least to push the data to Hadoop. And what they do instead to push the data to Hadoop, instead of using the native APIs and to use Kerberos, they use the REST interface, just like HDFS REST interface or HBase REST interface. And those interfaces, unfortunately, in bold, we haven't secured them. So this is not very good. Another problem we have is that the data is not encrypted. We also have a lack as for audit, so logging. We don't do a good job at that. And then the permission systems we have on HDFS, HBase, and Hive is not very strict. So as a result, our security departments doesn't want us to push some personal identifiable information into Hadoop. And this is really annoying for a lot of people, mostly business people. Those guys would like to be able to answer to questions just like, hey, the women's between 30 and 35 years old, what are their most favorite products? Well, obviously, if you're not able to have the age of your customers or the sex of the customers in Hadoop, you cannot answer those questions. So we're losing a lot of very interesting use cases. And if we go with the cloud, at least with Google, then we would solve those kind of questions. So what are the advantages of working with BigQuery? First, it's not just on BigQuery, this one. All the data is always encrypted, either on a network or either on disk. Then, the second advantage with BigQuery is that it's serverless. That means it's just a service. You don't care how many servers there are. You don't have to maintain them. So you don't have to worry about, hey, is my operating system up to date? Is my application patched? Well, this is a job patching the servers and the applications. Well, that is quite painful at Bol, and you no longer have to do that in the cloud. And we no longer have Kerberos, which is very good. Google has another way to authenticate. So this is another problem removed. Another topic with BigQuery is that we have just one single point of access control. When before we had different permissions for the REST interface, another one for native API, and in Hive you can kind of have a backdoor and access directly the files. Then in BigQuery you just have one point of control and everything is secured with this single point. So this is another thing that security guys really like. And I've been discussing with them, and they agree for us to push PII data on BigQuery. So how we would do that, because you still need to secure this data. So this is not as advanced as if you look at solutions just like Rangers to protect your data. You have to rely on doing some views, to create some views on the data. And we would have some public views where everybody could access the tables, all the columns, but not the columns that contain sensitive information. And then you would also create another set of views that will be the secured views, where here you have all the columns, but only some few people in your company could access this information. And the last topic, security people wanted us to have, is logging. You need to have very good logging. And this is what you have in BigQuery, the kind of logging. BigQuery is going to log everything for you, and you have a lot of information. So here you can see, for instance, the query I'm doing in the middle. You can see my name a bit upper. You can see my IP. You can see also when I've been executing this query, how many bytes have been processed, and you can even know if the query was success or not. So very good, and that means that now, if we go to BigQuery on the cloud, our data is going to be more secure, and we're going to be able to answer all those PII use cases we cannot answer now. And now, the last topic about the presentation is what kind of strategy should we use to migrate? Should we lift and shift? That is, we take our code, we push it to the cloud, and we try to change it as less as possible. Or should we use, well, native tools from Google? Those are kind of the two strategies you could find in general. And because we have so many teams, so many development teams working with Hadoop right now, and so many code that has been written, well, we wanted to use the first approach. That is, we want to do lift and shift and avoid them to do some kind of lot of refactorization. So this is a bit what we try to do. That is, well, using Dataproc. Dataproc is a tool in Google Cloud that allows you to create very easily some Hadoop clusters. You can create as many Hadoop clusters as you want, and well, as you want to pay for them also. And it's very fast. You can create a new Hadoop cluster in theory, 90 seconds. In practice, it takes maybe 2 minutes. And what you could do is, well, what we wanted to do is to define, well, one Dataproc cluster for every team we had, or maybe one for each job. And when the job is finished, you just destroy the cluster. And that will solve, well, two problems we have now in our current Hadoop cluster on premise. That is, well, capacity issue. Well, now all the teams will get all the Hadoop power they want as long as they want to pay for it. And the second one is configuration issue. I mean, you can create your own Hadoop cluster with your specific version, specific utility tools, whatever. And the good thing also, as I said before, if you do just a lift and shift, you don't have to change your code. So you can just reuse your current MapReduce jobs, pick code, Hive, Flink, whatever. But, well, we tried this approach a bit for some few teams, part of our POC. And finally, well, we discovered maybe this is not the best way to do that. Where first, we got a kind of consolation of some of the pilots from the financial department, because they said, oh, well, your big tables that you're using is costing too much, so you have to switch to another technology. So yeah, we had to give another set. Another problem we've seen is, well, the use of HBase we're doing now on our current Hadoop clusters is not very good. We're doing some kind of mistakes on our designs, and it would be a bit stupid to migrate to the cloud and, well, to have exactly the same mistakes. Those data that is in HBase, most of it, well, maybe should be in Hive or BigQuery. And another reason, well, to avoid doing lift and shift is that if you go to native Google tools, then you're able to be much faster and also, well, cheaper. Let's give an example. This is a comparison of Hive between BigQuery. Yeah, we can see the number quite well. So I've been running several tests with different kind of data, different queries. Most of it on the top are kind of very simple queries. The last one is an ETL process, so much heavier, with more than 300 columns. And you can see that on average, BigQuery is 10 times faster. And when you look at the ETL process, then it's 40 times faster. So it's much faster than Hive in general. And to be honest, on those tests, on those benchmarks, I also kind of tune a bit Hive in order to make it a bit, well, way faster than what it is right now on our production system. Oh yeah, and this sentence at the top, this is me talking to the Oracle people to give them my feelings about, well, BigQuery. And, well, because they're using Oracle, they were a bit angry hearing that. So BigQuery can be an alternative to Hive. And now we have a lot of jobs working with Pig. So we need also to find an alternative. So what would be the native tools for to substitute Pig in the cloud? So you could still use BigQuery if you want. In that case, well, that means, well, that would be more maybe for business people or SQL people. But if you like to program in Java or, well, Python, Scala maybe, well, then Beam could be an interesting alternative. So what is Beam? Basically, Beam is a kind of a framework that allows you to write some code in Java, Python, and then it's going to be executed either in Flink, Spark, or Dataflow. And Beams gives us a lot of flexibility because now we can write it in and run it in our Flink environment on our current Hadoop clusters. And in future, if we go to Google Cloud, we can take exactly the same code and use it on Dataflow. So no need to change the code. And maybe on the future, well, maybe we go to the Google Cloud, but then we also doubting, is Dataflow maybe the best options? Because we see that there are some problems on the metrics on Dataflow. It's sometimes a bit difficult to debug. And we still think that Flink might be quite interesting. So maybe the future with Beam is going to be Dataproc, so Hadoop clusters with Flink on that. And the Beam code is going to run Flink. So to summarize a bit, what are the advantages we can see if we go to the cloud? First, we're going to have more processing power. Then the data quality, well, can be a challenge, but there are different solutions we've seen in order to improve these data quality problems. Then we would get more security. We'd be able to work with PII data and solve many use cases. And finally, well, we have to balance the strategy between doing a lift and shift or using the native tools from Google. And yeah, if you want to be part of, well, this migration process next year, if you want to discover more about Bol.com and well, Google Cloud maybe, well, just feel free to send me an email, talk with me. Thank you.